Hi, my name is Ng Chong Jing. Today I'm going to present a business case of why it is important to use machine learning in understanding social media users' behavior. I'm going to take the example of Elon Musk taking over Twitter in the year 2022, and I'll show how using NLP we can model the topics being mentioned by social media users and also understand the sentiment behind what they post on the platform. Also, I use engagement metrics to measure how impactful are each of these topics being mentioned. Let's start with the presentation. First, it's important to understand how social media, in a short span of 20 years, has evolved from a lifestyle sharing platform into a central tool in shaping public perception. It was Barack Obama's first campaign in the 2008 US elections was when it was the first time when a political party used social media as its core strategy to convert everyday citizens into volunteers by inspiring change, which outpaced other well-known counterparts such as George Bush and Hillary Clinton. Many political parties around the world replicated this strategy, and particularly in the 2018 14th Malaysian general elections, where the competing Pakatan Harapan Party implemented a more effective audience segmentation plan, and it reached a wider range of social media users by live streaming events. This actually enabled them to win the elections over from the Barisan National Party, who had dominated the Malaysian elections for almost 61 years. Realizing the potential of social media to actually directly influence public opinion, Elon Musk moved to actually acquire Twitter in the mid of 2022 as an effort to preserve free speech in social media. However, this sudden act actually drew numerous reactions from the public, both the positive and the negative ends of the spectrum. Elon's reputation, which has been steadily increasing over the years due to SpaceX and Tesla's successes, have definitely been shaken to its core as a result of this acquisition. Now, let's look at the more detailed timeline of the events that occurred in a span of nearly 7 months in the acquisition of Twitter. Starting from March of 2022, Elon Musk became the largest shareholder, which he then offered to buy Twitter at $43 billion. After some deliberation, Twitter actually accepted the offer at $44 billion, but only to suddenly be told to put on hold in May, as Elon stated that there are unprecedented amount of bots and spam accounts in Twitter user base, which actually would arguably devalue Twitter's valuation. So this is where things turn ugly, when Elon finally decides to terminate the acquisition in July, which prompted Twitter to sue Elon in a Delaware court. After much negotiations, both parties were actually finally able to move forward with the acquisition and closed the deal finally in October of 2022. Now, these events are actually a perfect example to describe why it is challenging to analyze social media data. Aside from social media texts being unstructured and complex, the sheer amount of data may be up to millions of posts, and thus traditional methods of random sampling are simply not enough to effectively analyze the data in a timely manner that is crucial for businesses. Furthermore, conventional methods of analyzing the share of voice based on the engagement figures isn't enough to explain the thoughts, expressions, and the sentiments of the public. Therefore, there is actually a strong need to build an analytical model that analyzes social media data at scale by combining both quantitative and qualitative methodologies. From a business perspective, however, having this ability to analyze public opinion at scale is crucial in the age of social media. This is where one single step to actually determine the outcome of how a business could secure the support of its customers or it might spark a crisis that is incredibly hard to recover from. Now, for example, in 2017, during a taxi strike in New York's JFK airport, they protested President Trump's new immigration policy. And as a result, demand spiked and Uber actually turned off surge pricing to ensure commuters could reach the airport on time. It was a logical business decision to actually cope with demand. But however, the public saw it as an attempt to break off the strike and to profit off refugees who are the main people who organized the strike. And suddenly, the hashtag of delete Uber was trending, and about 500,000 people deleted their Uber accounts within a week, which actually gave rise to a new competitor called Lyft. Other examples of crises, such as BP's oil spill and Samsung's corruption scandal, each highlighted the need to monitor public perception in near real time. All of this ended up costing the firms millions of dollars, which took them years to recover from. Therefore, this actually sets the objective of this study, which is to utilize a mix of quantitative and qualitative methods to analyze large volumes of social media data and to understand how users behave and their reactions. The analytical model that I propose to build is based on these three core components. Each of them is designed to address a type of social media constraint. The first one is topic modeling, where a natural language processing model called BERT topic is used to cluster social media texts into related topics. This organizes all the unstructured texts into manageable chunks based on the issues that are being mentioned in the social media posts. Therefore, it provides the reasoning why social media users post the content that they intend to. Next, we look at the sentiment of the texts that are being written, whether the writer expresses a positive or negative viewpoint, and is assigned a score. Generally, this enables us to understand what are the emotions behind the writer's reactions towards the issues they are writing about in social media. And last but not least, we analyze the engagement metrics of each post to measure how impactful each topic is in influencing public opinion. Generally, social media posts that gained a higher number of likes and shares indicate that a larger audience has viewed and interacts with the post. This in turn prompts the social media's recommendation algorithm to push the content to an even wider audience, thus making it a good indicator to quantify the impact of the qualitative analysis that was generated from topic modeling and sentiment analysis. Therefore, with these three components, it provides a holistic view which provides a measurable impact to the qualitative reasoning and the context behind social media data. Next, we look at the data collection and the analytical methodologies of this study. The dataset that was sourced from is actually from Kaggle, which collected a total of 10,000 tweets from Twitter, which mentioned specific keywords related to the 2022 Twitter acquisition. It was collected from the period of July 16th to July 18th of 2022, and it recorded a total of 80.8 thousand engagements. The dataset is cleaned by removing punctuations and URLs, and potential bot tweets were filtered through analyzing features of the tweets. One such feature is that it was key in identifying bot posts was that the bot accounts generally post twice the daily amount of human posts. This means that the bot posts were automated throughout the day regardless of the time. With that, a total of 490 suspected bot tweets were removed from the dataset, leaving behind 9,510 tweets and 77.8 thousand engagements. Now, with the cleaned dataset, I applied topic modeling and sentiment analysis techniques based on the BERT natural language processing model. BERT stands for bidirectional encoder representations from transformers. This was developed by Google and the University of Toronto in 2018. It was based on the transformer architecture, which was a giant leap forward from the previous NLP models. Transformers work on a self-attention mechanism, which basically means that the relationships between all the words are computed simultaneously, which allowed for the parallel processing, which is much faster than conventional methods of processing each relationship separately. Thus, the word sequential modeling for previous NLP models. With this, it actually enabled the model to be trained on datasets that are up to 3.3 billion words, which are much larger than previously thought possible. Besides that, the transformers architecture actually masks 15% of random words and analyzes the words before and after in order to predict some missing words. Therefore, this enables the model to predict the next sentences and is able to understand the contextual nuances in words. The most classic example to illustrate it is the word bank. When it appears in the word riverbank, it's often used together with words like boat and nature, as opposed to a word like bank vault, and often is used in words together like money and gold. Now that we have a basic understanding of what BERT is, we look at how BERT topic is used to extract topics from unstructured text data. BERT topic is actually a modeling library developed by Martin Grotendorst that is based on the BERT NLP model. How it works can basically be simplified into three broad steps. The first is document embedding. In this step, the text data from social media is tokenized by splitting into individual words. They are then passed through the default transformer model called SBERT to uncover the contextual meaning of each word. Now, with the embeddings in the entire sentence or the paragraph, it moves on to the next step of document clustering. It is clustered by assigning a vector value with a high number of dimensions, much like text being represented as dots in space that are placed in all directions in relation to each other. Dots that are closer in meaning to each other are placed closer together, while texts that are different are placed further apart. So because of the dimensions, which are omnidirectional in all directions, UMAP, a uniform manifold approximation and projection, is a method to flatten the dimensions while retaining the relationships between the dots. It's like making a map of the dots where the multiple clusters can be seen together. Next, HDB scan, hierarchical density-based spatial clustering of applications with noise, groups all the clusters together, which represents a single topic. The final step of BERT topic is topic representation. It is where TF-IDF, term frequency, inverse document frequency, is a feature to find important words within the clusters. So words that are unique obtain a higher score, such as Delaware Court, that may appear in a limited number of tweets, as opposed to Twitter that may appear in almost every other post. Subsequently, this list of keywords is what each cluster of topics represents. Therefore, it indicates what the issue is being mentioned in the cluster of tweets. And with these three general steps in BERT topic, there is no need to actually predefine the number of topics to be extracted from the unstructured text data. Thus, it is ideal to analyze social media at scale. Next up, we use BERT to analyze the sentiment of each Twitter post. Due to the features of next sentence prediction in BERT, the model itself is inherently capable to assign sentiment scores to text data. And the ability to understand contextual meanings of words, as the example given here, is for the word Python as a programming code or as a living animal. BERT, therefore, is found to be more accurate than traditional sequential machine learning models. Nevertheless, one might ask, why would it be important to understand sentiments of social media data? Besides understanding whether the public is happy or unhappy towards an issue, a study by Brian Knudsen and his colleagues in 2024 found that social media content that is perceived as negative has a higher chance to go viral in the platform. Therefore, this highlights the importance for us to understand the sentiment of unstructured data. Finally, the last step of the analysis is to measure the engagement metrics. This is where the number of tweets per extracted topic is counted and is ranked against each other. The number of comments, likes, reposts, and views are also summed up to make the total number of engagements, which actually indicates how popular a particular tweet has spread among users in Twitter. With that, the methodologies, we now move on to the results and the findings of this study. First, we look at the results of bot detection. I found that from the 490 bot tweets, there are actually 3 defining features that make them easily identifiable as bot posts. The first being that similar content can be found across multiple accounts that seem unrelated to each other. From this, it was obvious that the users have utilized multiple accounts to push similar content in order to maximize viewership. Next, I also excluded news accounts to avoid biases in sentiment analysis. This is because news accounts, regardless of whether they are automated or not, is not the target subjects of this study. Thus, removing news posts is actually beneficial towards refining the topic model and sentiment analysis. Now, the last and the most obvious identifier of bot accounts is that the posted content usually only contain tags of other usernames. It is without any meaningful words to explain what the post is about. Generally, human authors do not actually post in this type of content, and it indicates that the bot accounts attempts to maximize viewership by tagging as many viewers as possible. As a result of these 3 features, 85 bot accounts were identified to have posted 490 tweets in the dataset. A majority of 82% of them seem to post between 4 to 6 tweets daily on average. Presumably, it is in order not to trigger the automated bot detection functions of Twitter. Nevertheless, this bot generates about 2,967 engagements, which is only about 3.7% of the total number of engagements. A large majority of those, which is 1.7 thousand engagements, are specifically on the news tweets by Reuters Twitter's accounts. Therefore, from these results, I have determined that the overall impact of bot accounts is low in this study. Next, I applied BERT topic to extract 49 topics out of 5,519 tweets. This was 58% of the entire dataset, where the remaining 42% are generally random posts without specifically identifiable keywords that could be clustered together. Out of the extracted topics, the top 25 topics covers 86% of the total number of clustered tweets, which is then further summarized in the bar chart as shown here. Now, a large majority of the tweets talk about the failed Twitter deal and the happenings of the legal battle that ensued as a result. Then, I applied sentiment analysis to the dataset and found that the Twitter users are largely unhappy with the sudden halt in the acquisition and also the legal battles. An overwhelming 74% of tweets are rated negatively at a score below 3. And to verify the results, I picked random samples out of the dataset and actually found that 92% of the scores have been assigned correctly. This actually further substantiates that the BERT NLP model performs well by being able to understand the nuances of the human language and correctly assign the sentiment score. With the generated topics and the sentiment, the results are all cross-referenced with the number of engagements to form a combined analysis that shows the impact of each topic. Overall, only one topic, which is the user text on posts, scored a neutral sentiment score of higher than 3. But it, however, has a low impact of only 228 engagements. The remaining topics are all scored negatively, with the number of tweets being discussions on the failed Twitter deal, with a total of around 20,200 engagements. However, with a closer look at the results, the combined incidents where Elon Musk personally intervened with the legal proceedings or stated his justifications on pulling out on the acquisition actually scored among the lowest sentiments, as highlighted here in yellow. This has a highest combined total of 24,133 engagements. Therefore, this shows that Twitter users actually disagree with the way Elon Musk halted the acquisition and moved to interfere with the legal battle to turn things to his favor. With the generated results, I arrived at 5 actionable insights from the perspective of how businesses can apply this analytical model. The first is that by analyzing the entirety of the dataset instead of picking random samples, fragments of a minority of issues may actually combine to make up the majority of public opinion. As with the case of this study, the common denominator was the way that Elon personally halted the deal and intervened on the legal battle that resulted in the largest negative impact on public opinion. Which is why it is absolutely essential for any organization to carefully tailor their communication to the public in order to manage their perception in moments of crisis. And it would be more beneficial for Elon, in this case, to be more prudent in strategizing ways to exit the acquisition, rather than communicating his direct thoughts, which may have resulted in a long-lasting damage to his reputation. Therefore, public sentiment, as shown, is also a good measure of how effective an organization's public communication can be. Nevertheless, this study also highlighted the importance of combining both quantitative and qualitative analysis, as one single methodology alone is not enough to illustrate the complexities and the patterns of social media data. And in my opinion, the bulk of the value lies in the unstructured text of social media. That is where the collective reasoning, when quantified by the quantitative measures, can provide the best actionable insights for an organization to make an informed decision. In conclusion, through this study, I have demonstrated the use of both quantitative and qualitative analysis to analyze social media data and actually derive actionable insights. This is actually arguably essential for businesses to make informed decisions, to communicate to the public and manage social perceptions in order to avoid crisis and actually maximize the potential for success. However, as the methods demonstrated would require the use of machine learning algorithms in order to analyze large volumes of social media at scale. This is because the timing of responses is very crucial when a business needs to communicate to the public and contain problems before they actually become too big to handle. That concludes my presentation, and I hope you enjoyed it and learned something from it. Thank you for listening.